Just so 1, 2, and 3 are all the same kind of questions. I'm going to briefly go over an example or two from 4, and then one example from 5. Now that's the scary ones. The ones on 5.
I'm having the best. Oh my God.
Okay, so that's 4A. And you'll notice if you look right above the question, the difference between this one and the other ones
Ooh, all of them.
are what?
You have to do all of them.
Yeah, it says that this is solve it for all x's in the interval from negative infinity to infinity. So on the other ones, basically what we would do is we'd say, oh, well, one cycle around the unit circle would go from 0 to 2 pi, and I just want to find the locations, the numbers that are there in that interval. On this one, it's the same locations, but the idea is like, say you find a location that works, say right here, do you see how you could then add 2 pi onto that number and you'd still have the same cosine or sine value or tangent value or whatever?
Mm-hmm.
So that's all we're going to do. So they're actually these are pretty simple questions because you find the locations you want and then you say, well, that location plus or minus any number of 2 pi's that you want. So here's how you do it. Step 1, solve it like we usually do. Cool beans. And then you'd say, well, what locations on the unit circle have a cosine of -1/2? So pi over 3 has a cosine of +1/2, so we'd have to go one more third.
No, it's negative.
So basically, here's my triangles. So hopefully you'd identify, okay, this is the triangle I want, the 30, 60, 90, but I got to orient it like this because that makes my horizontal leg be -1/2. That makes sense? And then likewise, this guy and then, so you got 2 pi over 3 and 4 pi over 3. And then so the notation, so if everyone's fine with the fact that you can go, well, 2 pi over 3 works, but also couldn't I add on another 2 pi and be 8 pi over 3? Or add on again, be 14 pi over 3? And just do that as many times as I want. So what you should do is you say plus 2 pi n. Then you do the same thing over here. You say 4 pi over 3 plus 2 pi n with a condition. Oh, it's not a condition. Just you say, well, what does n represent? N represents any integer. We all cool with that?
Okay, wait. I'm sorry. Where did n come from again?
And so it's like, so you agree 2 pi over 3 is the solution. Do you agree that if I added another 2 pi onto that and had like 8 pi over 3, that would also be a solution? So that's what this is doing. It's saying 2 pi over 3 is a solution, and you can add on any multiple of 2 pi onto that number, and it would still be a solution. That makes sense to n? And here we're saying kind of what is n. If you want to be really fancy, you could say this. You could say n is any element of the integers. That one really flexes on them.
NEZ.
And so this is n is an element of the integers. This
That's
means
Z. It says nodes.
it's just a symbol that means the integers, the set of integers.
Nodes.
Nuts.
Wow, got him. Such a good meme.
I'm laughing.
You totally debated me.
Thanks, bro.
Sean, you debated.
I don't know that. I don't know the baby. But
DeBaby's this guy that looks exactly like Sean Patrick.
Yeah, Sean Patrick, basically, look on my face, and then you know what the baby looks like.
Yeah. He's a celebrity, so it's crazy. We noticed that like he looks like if you saw DeBaby, you'd probably think it was Sean Patrick. That's how crazy. Such a good meme. That's high levels. Even though I'm supposed to be on detox for memes.
Sean, what does the baby say?
What is, let's go.
The baby says, levitating, featuring Lily.
No, stop.
Yes.
What is that a song? Let's do one more together. 4B.
He says the lyrics in the song.
Yeah,
He does not say the title.
let's go.
This one is the same kind of idea, but the end, just fair warning, it might confuse you a little bit, the last step.
The last one?
What's the first step to solving something like this?
Vector.
Factor out the common factor. Are we all cool with that first step?
Yeah.
Okay. So either this guy is 0 or make sense to everyone?
Yes.
Okay. So where are the spots on here where the tangent would equal 0? Keeping in mind that back to the original unit circle, on a unit circle there's an x and a y, and the tangent is given to us by the opposite over adjacent, so it's the y over the x. So it's anywhere where the y value of your point is 0. So where's that?
0 and pi.
0 and pi, very good. You feel okay with that?
Yeah.
And then where would the tangent equal 0?
1 pi over 4.
Pi over 4.
5 pi over 4. 7 pi over 4.
No.
No, those are negative.
You made me write 7, Sean Patrick. I was trying to write a 5. These guys have a tangent of -1. So are we okay with this?
Yep.
Okay. So if the question was just find all the values from 0 to 2 pi, we'd be done. We would have found the 4 values, but I'm gonna leave me some space here to write the true, the more concise answer is gonna go here. So watch this. I don't know. Hoping to get some feedback from you guys to see if this is confusing or if it makes sense to you. This is the long way to do it. Woo.
So there is a shortcut.
Yeah, this is the long way. Is this wrong? No, it's not wrong. It says that I could add any multiple of 2 pi to any of those 4 locations as many times as I wanted, and I'd still have a solution. We all get that idea? Okay. But here's the thing. I'm going to lump these guys into a single statement because, let's say I have a solution here. I can add pi to it, add pi to it, add pi to it, add pi to it. See what I'm doing that?
Yeah.
So Rita, pay attention. Add pi, add pi, add pi. So what I can do is I can just say it's just any multiple of pi. That's the part that if you find that confusing, you're probably in good company. A lot of people find it confusing. But so instead of saying I can add 2 pi onto either of these locations, I can just start with one of them and add pi to it. And it has to do with the fact that the tangent function, if you think about it, if you have a tangent value, if you have a location and you add pi to it, the tangent stays the same. And how about this guy? You guys see how this guy, if I add pi to him and continually add pi, same thing. So I could also say a fourth of pi plus any multiple of pi. And again, the
Is there a shorter way to write? Oh, never mind.
to write this.
No, I got it.
N in Z. Fancy Z, that is. Fancy Z. Okay, you guys feel okay about this?
Mhm.
All right. Just a heads up, you often, with the sines and cosines, you usually can't do this because if you add pi to a sine, or if you add pi to an angle, usually the sine is the opposite of what you used to have. That makes sense.
Mhm.
And by usually, I mean always. So anyway. All right, you da babies. Let's go. Was there actually a DeBaby in Fortnite, or was that just a VMAX?
Well, Fortnite, I think they said they were gonna add the baby into the game, and then the baby responded, "I would rather die than be in your game."
I've always wondered, how do they get do they pay for all that IP that,
Probably.
like every single superhero and sports star that's in Fortnite, they pay them? It's gotta cost a fortune.
It doesn't cost too much because it's a lot of promotion for that company as well, though. So it's probably just
Okay.
like a brand deal, like, hey, we're gonna promote you through our game to the children's.
Like a symbiosis.
Yeah.
That's like, you know the
And we
Reese's
get
Pieces
your
story
audience.
Yeah.
with E.T.?
Yeah.
Yeah.
It's like,
Pretty
hey,
interesting.
we'll give you our audience, you give us your audience. It'll
Yeah.
be good.
Ah, it's Marcus sucks. There's a line drive. Stay still, Jaden. Oh,
Buckets.
buckets. Okay. Last thing. Let's do like two of these. First one. All right, brace yourself. These ones tend to be the hardest ones. Typically. What is that? What does that move?
Scared.
Is it the new dab?
That's
Yep.
lost.
That's the floss?
I never heard this one.
Okay. Step one, subtract 5, divide by negative 10. You get this. Okay, now. Don't shout it out if you know it. I want everyone to have a chance to think about this one. Try to see if you can reason out one of the solutions to this. And I'll give you a hint. The hint is the sine of what would be 1/2. So think about that. The sine of what equals 1/2. And then to consider that, and then go, okay, well, what would x have to be? All right. Anyone have a thought that they haven't answered?
I've never.
Except
had a thought
AJ?
in my life.
As much as I appreciate your answers, AJ. Anyone else?
No.
Come on.
Trying to think.
Got you, Paul.
I over 6, you guys 3.
Okay, well, let's say that what you said is the answer to, I was wondering earlier, the sine, my marker, failing me.
H.
Wow, what a shot. That went right in the basket. Can you even see that? I'm not sure I can see that. That marker's brand new.
Throw it away.
Yes, so we agree, do we all agree that the sine of pi over 6 equals 1/2? We agree that's true, right? So therefore, this is gonna be true if 2x were to equal pi over 6, right?
Yes.
So then what's x?
5/6.
Close.
5/12.
Pi over 12, very good. A 12th of pi. How do we feel about that?
Not good at all.
Yes, why, Sarita?
Because we cannot, it's not.
Where's
one
the
of famous
36 to 90?
triangles.
It's not famous, but he does live on there. Where's pi over 12?
He's
Right.
right in between pi over 6 and 0.
Yeah, just a wee lad. How many degrees do you think that is?
Probably like
15.
15. 15 degrees. Okay, let's keep going. What?
What?
Anyway,
It's all right.
she memeing over there. It's also true that the sine of, what's another angle that has a
5.
5 pi over 6? Very good. That would also equal 1/2. Okay, so then I could use the exact same logic and say, well, it could also have been the case that that 2x was equal to 5 pi over 6. And what solution is that going to produce? 5 pi over 12. Okay with that? There could be like an or here. Or. What you usually do in practice, because this is you separate the possible numbers by commas. You would write 2x equals pi over 6, comma, 5 pi over 6, comma. You get that? Just shorter that way. Anyway, so where's 5 pi over 12? Well, 6 pi over 12 would be half pi. So we must be just a little bit shy of 90 degrees, right? How many degrees is this? 75. Right, is there confusion or?
Yes, and I
Yeah.
don't know.
How does it work?
Well, let's just rewind a step. Do you understand why, like this stuff in blue? You agree with that? Then you agree how if this is true, if the sine of this equals 1/2 and the sine of this equals 1/2, then this must equal this.
Yes.
Okay, and that's what we write right there. And do you get how we're going from there to there?
No.
Okay, so we're just basically saying, I mean, dividing by 2 is the same as multiplying by 1/2, right? So you're going 5 pi over 6 times 1/2. So 5 pi times 1 is 5 pi, 6 times 2 is 12. And are you cool with getting from there to like locating it on the circle?
Kind of.
Well, so 6 pi over 12 is just half a pi, right? So that's 6 pi over 12, so we're just gonna say we're a little bit short of that. All right, we're not done yet. It's probably pretty early for you guys to have this like intuition built up maybe, but this just feels like it's missing stuff.
Yes.
These solution sets usually exhibit some kind of, what was that? Some kind of symmetry. And this just has this feeling of like there's a lot of empty space there, okay? So what's gonna happen here? So I'm gonna go sine. You're like, wait a second, didn't you already list out all the places on the unit circle with a sine of 1/2? Yes and no. I located all the locations, but pi over 6 is equivalent to 13 pi over 6. This is the confusing part. This is the part that you had to brace yourself for. Do you agree with that?
Yeah.
Add 2 pi into it. So what? You're like, well, bruh, wait a second. You just said that we're only looking for numbers between 0 and 2 pi. Yeah, but when we divide it by 2, it will be between 0 and 2 pi. So you get what I'm saying? So 13 pi over 6 could be equal to 2x, just like before, which would give us an answer of 13 pi over 12, which would be a little bit past what?
The halfway mark.
Yeah, a little bit past pi. So there's 13 pi over 12. You feeling one more solution?
Yeah.
So I just, to be clear, we used this fact. Definitely a less commonly used fact. This one comes up all the time. This one comes up all the time. This one is coming up right now. And how about this guy? If you add 2 pi onto 5 pi over 6, you get if you're having trouble with that calculation, it just goes like this. You have 5 pi over 6. I want to add 2 pi onto it. 2 pi is 12 sixths. Yeah?
Yeah.
So how many sixths do I have here then?
17.
17 pi over 6. So I could have said, I'm being so thorough here, guys. You guys better leave me a good Yelp review.
Of course.
So it's also true that the sine of 17 pi over 6 is equal to 1/2. So therefore, you guys see why that whole comma separated thing would be more convenient. I would be doing that going forward. I just wanted to.
Or in the triangle.
Huh?
25.
Yeah,
Yes, triangle.
No, it's just windmill.
25?
Oh, windmill.
Well, hold on. We all get how we got 17 pi over 6, right?
Yeah.
And how that would be right here. 17 pi over 6. And the thing is, we're actually done. Because if you circle back again and go 25, yeah, you're talking about the 25, right?
Yeah.
So if you went 25 pi over 6 and divide that by 2 to turn it into 25 pi over 12, that's over 2 pi. So that's beyond our interval that we care about. Okay? So there's the answer. The answer is
Jesus.
Nikita?
Like, there's a lot of answers.
Yeah, there's 4 answers.
This is.
Did it upset you?
Yeah.
Upsetting.
My feelings are hurt.
You were upset spaghetti? Were you in the class with Callie Storm? Were you in the same class? Whatever happened to Callie Storm?
She moved back to Whitefish.
Oh.
David Doe.
Well,
Kelly Storm kind of looked like the baby.
Nah.
well,